Hey there guys, we're going to start in lesson 4.9, introducing you to some inequalities and talking about how we can use these inequalities to represent some real world situations here. So you've seen greater than and less than before, and we've compared things using these. The new inequalities we're going to talk about, this will be read greater than or equal to, less than or equal to, or not equal to. All right, so going to look at a couple of examples here of where you might see these and what these look like. So this first example here, any number less than or equal to 3, then we can have a lot of answers. Again, the key here, it says any number less than or equal to 3. So any number, let's just call x, and we'll say x is less than or equal to 3. We would write that like this: x is less than or equal to 3. All right, and that means x, any number less than or equal to 3 would make this true. So 2, 1, 0, negative numbers. You could have fractions and decimals in there as well, but it just has to be less than, or it can equal 3 exactly. Okay, another way to word something might be like the second one: any number that is at least 2. And if it's at least 2, that means the any number, we'll call that x, is greater than or equal to 2, because it's at least 2, so it's got to be 2 exactly or bigger. And then another variation of how to talk about this: any number that is no more than 6. Okay, if it's no more than 6, it can't be bigger than 6. So any number we'll call x is less than or equal to 6, because it can be exactly 6, it just can be no more than that. So they can word these a lot of different ways, because there are certain situations, again, where it can be greater than 2, but it could be exactly 2. So we're just kind of adding to our inequalities here and talking about these a little bit today, and we're going to jump into some real world situations. So again, we'll kind of erase these here and jump into some real world examples where you could see situations where you need these inequalities. All right, so here's the number situation. We'll look at number 2 right here. The sign to the right hangs over the checkout counter in a grocery store. Explain what you think the sign means. So in the express lane at a grocery store, you have to have 10 items or less to use that, so we can get through the line a little bit more quickly. For people that have a small amount of items, they don't want to wait behind someone who has 40, 50 things in a grocery cart, so they make this for convenience. So that means for 10 items or less, it says to use this lane, you must have only 1 through 10 items. Can't have more than 10. You could have 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. We wouldn't have fractions or decimals here because you can't have parts of items that you can use. So we're going to name a variable for what we think we want to call this. And again, remember, we can use a variable and call it what we want. Okay, but let's say, again, let's just use the x equals the number of items that you're buying. Nice and simple. It's your number of items. So the inequality that represents being able to use this lane is that x has to be less than or equal to 10 items. Okay, and we can also write that this way. Okay, if you flip the 10 and the x around, you have to flip the inequality around too. So 10 is greater than or equal to x, which still means x is less than or equal to 10. Either way you can write that. It's correct. And this represents this situation. And x could be, again, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10, because it can be exactly equal to 10. Okay. You would have to put a constraint on this, and this is stuff we'll talk about later, that x has to be a whole number because you can't have partial items. But we'll talk about that as we get a little bit more advanced. Sorry, this kind of couldn't see that there, so I'll rewrite it here. 10 is greater than or equal to x. Again, these two represent the same thing. Okay. One more example right here. The sign to the right is posted near a roller coaster at an amusement park. Explain what you think the sign means. It says you must be 48 inches tall to get on this ride, which means for safety reasons, you have to be so tall, again, so you don't possibly fly out of the roller coaster if you're too small to fit in how they've got you strapped into that roller coaster. So explain what you think that means. You have to be at least 48 inches tall to ride. Okay, you have to be at least 48 inches tall to ride. So in this case, we're talking about how tall you are. So it doesn't matter what I call the variable. I'll call it x again. Okay, in this case, x would equal the number of inches tall you are, possibly you could write. So x is going to be the inches tall that you are. So you have to be at least 48 inches. So your inches have to be greater than or equal to 48 in this case in order to ride this ride safely. We could also write that again as 48 is less than or equal to x. Again, if we look at this, we'd read it 48 is less than or equal to x, which means x is bigger. The open mouth is open towards x, just like it is here. So both of these mean the same thing. You could write it either way. Again, looking at these in real world situations where we need inequalities, these would be two examples. So on your practice slides, you guys will be taking a look at some other real life situations, trying to write inequalities to match them. And that is the main point of what we're trying to do today with these inequalities and showing you how we have them in the real world.